it's time for you to learn about UML state diagrams. A state diagram is a technique that you can use to describe how your system behaves and responds. When an event occurs, you note how a system acts or behaves. Let's think of a person. To make things simple, let's say that this person can have 3 different emotional states: happy, sad, and angry. State diagrams show states as nodes, like the following. You will learn more about this later, but I'll draw a filled circle to indicate the start state of this diagram. Usually, I wake up happy after a good sleep. Let's say that this person starts their day happy too. During the day, maybe something happens to anger this person. Let's say that the person accidentally stubbed their toe on a table. This would change their state from happy to angry. In state diagrams, arrows are used to represent events to transition from one state to another. While this person is angry, they might notice that it's raining outside, and this makes the person sad. So this would change their state from angry to sad. This is how a state diagram works. The state diagram follows the states of a system or object and shows changes between the states as events occur. Right now, this is a simplified version of a state diagram for the mood behavior of this person. We will go through more UML state diagram conventions and examples later. State diagrams can describe a single object and illustrate how that object behaves in response to a series of events in your system. A state diagram illustrates object behavior by depicting the changing states of an object. These states change in response to different events. A state is the way an object exists at a particular point in time. The state of an object is determined by the values of its attributes. For example, think of a car. A car with an automatic transmission can be in different states: park, reverse, neutral, and drive. When a car is in reverse, it can only behave in a certain way. It can move backwards. If you wanted to move in a forwards direction, you would have to change the state of the car accordingly. This is how you can think about the states of the objects in your system. When an object is in a certain state, it behaves in specific ways or has attributes set to specific values. Using UML state diagrams, you can express the different states of your objects and how the states will change when an event occurs. To better understand how to create UML state diagrams, let's actually create one together. Let's use a vending machine as an example for our UML state diagram. First, I'll indicate the start of this diagram with a filled circle, like we did earlier in the mood state diagram. Every state diagram has a filled circle to indicate which is the starting state. The vending machine starts in a state named idle. This is when the vending machine is waiting for coins to be inserted. I draw states as rounded rectangles. Let me explain states in more detail. Each state has 3 important sections: a state name, state variables, and activities. Each state should at least have a state name. A state name is as it sounds, the name of the state. These names should be meaningful for the states of your object. For example, a car in reverse would have a state named reverse, or a vending machine in a waiting or idle state would have a state named idle. State variables are data relevant to the state of the object. For example, using a course as an object, a relevant variable is the number of students enrolled. The course would be in state full if this variable was at the course capacity. Activities are actions that are performed when in a certain state, and they're displayed at the bottom. There are 3 types of activities for each state: entry, exit, and do. Entry activities are actions that occur when the state is just entered from another state. Exit activities are actions that occur when the state is exited and moves on to another state. And do activities are actions that occur once or multiple times while the object is in a certain state. To explain these activities, let's use a traditional alarm clock that uses a bell as an alarm. An entry activity for when a clock enters the ringing state is that the clock releases a spring to ring a bell. When the clock leaves the ringing state, it will relock the spring as an exit activity. When the clock is actually in its ringing state, the clock continuously rings the bell, and this is its do activity. Now back to our vending machine example. When the vending machine enters this idle state, it always displays the total of coins inserted so far. This means it is also tracking this total. I will draw these inside the rectangle. The state variable is total, and the entry activity will be display total. Inserting a coin is an event that could change the state of the vending machine. Events that could change a state label transitions between the states. You draw these transitions with arrows from one state to another. Each transition arrow will always have an event, and may have a guard condition and an action. The transition and action happens from a given state if the event occurs and the condition is true. As a basic example, suppose you are finished writing an online test. For your test to go from state in progress to submitted, the event will be click the submit button. The condition will be submission date is before due date, and the action will be submit test. Again, back to our vending machine. Suppose, when in the idle state, someone inserts a coin and the total so far is less than the product price. Let's express this situation with the transition arrow that loops back to the idle state, with the event insert coin, condition total less than price, and action display insert more coins. But suppose, when in the idle state, someone inserts a coin and the total equals the product price. Let's express this situation with the transition arrow to a new state, named enough coins, and label this transition with the event insert coin and condition total equals price. Let's have an entry action for enough coins being display enough coins. When in the enough coin state, we have enough payment, so if someone presses the dispense button, the vending machine should release one of the product. We'll express this situation with the transition arrow from the enough coin state back to idle, and label this transition with the event press dispense and action total equals 0, dispense product. In either state, if someone presses the cancel button, the vending machine should return all the coins inserted. So we'll express this with two transitions from the two states, both back to the idle state, and label both transitions with an event press cancel and action total equals 0, eject coins. Here is the resulting state diagram. One element of state diagrams that's not shown in the one we just created is termination. Termination represents an object being destroyed or the process being completed, and is drawn as a circle with a filled circle inside. For example, when using a bank machine, you can represent it returning your card at the end of the process, and thus ending in termination. Not all diagrams have a termination like the vending machine. They may run continuously. State diagrams are useful for describing the behavior of a system or of a single object. For example, it can help you determine the different events that might occur during an object's lifetime, like different user inputs, and how that object should behave when these events occur, like checking conditions and performing actions. From the vending machine example, if I forgot to express canceling the order, I could see this easier on a state diagram than looking at source code. State diagrams can also help you to find issues in your system, like discovering a condition that you did not plan for, or help you to create tests. Knowing the different states of a system can help to make sure that your tests are complete and correct. State diagrams are a very powerful design technique that you can use to model your software's behavior. Using them along with the other UML diagrams you've learned will help you to create well-designed software.